Download this code from codegive.com, link in the description below. OK, let's embark on a deep dive into Guava cache with Java. This tutorial will cover the fundamentals, advanced configurations, and practical examples to help you master caching in your applications. Guava Cache, a powerful in-memory caching solution. Guava Cache, provided by Google's Guava library, is a robust, high-performance in-memory caching implementation. It's designed to be a more flexible and powerful alternative to java.util.concurrent.concurrentmap when you need advanced features like eviction policies. Automatically removes entries based on size, time-based expiration, and reference-based garbage collection. Refresh policies. Asynchronously refreshes entries to prevent staleness. Statistics. Provides detailed cache hit/miss information for performance analysis. Loading functions. Allows you to define how values are computed when they are not present in the cache. Atomicity. Guarantees atomic operations for cache entries. Prerequisites. 1. Java development environment. Java 8 or later is recommended. 2. IDE, optional Eclipse, IntelliJ IDEA, or any other Java IDE. 3. Maven or Gradle * for dependency management. Step 1, adding the Guava dependency. If you are using Maven, add the following dependency to your pom.xml file. If you are using Gradle, add the following dependency to your build.gradle file. After adding the dependency, make sure to update or refresh your project to download and include the Guava library. Step 2, basic cache usage. Let's start with a simple example to demonstrate the basic usage of Guava cache. Explanation *. 1. Cache builder. New builder * creates a cache builder instance, which allows you to configure the cache. 2. Expire after access. 5. Time unit. Seconds, * specifies that entries should be evicted after 5 seconds of inactivity, no reads or writes. There's also expire after write for eviction after a certain duration since the entry was created or updated. 3. Build, * builds the cache instance. In this simple example, we're not providing a loading function. 4. Put, key, value, * inserts a key value pair into the cache. 5. Get if present, key, * retrieves the value associated with the key. Returns null if the key is not present. 6. Loading cache. The cache builder.build method in this example is provided a callable to retrieve values from and add into the cache. 7. Expensive calculation. This is a placeholder function that simulates a computationally expensive operation. In a real-world scenario, this would be replaced with your actual logic to retrieve or calculate the value for the given key. For example, you might make a database query or perform a complex calculation. Step 3, building a loading cache. A loading cache is a more powerful type of cache that automatically loads values when they are not present. This eliminates the need to manually check for the existence of a key before retrieving its value. Explanation *. 1. Loading cache integer, string * creates a loading cache that stores integer keys and string values. 2. Maximum size, 1000. Sets the maximum size of the cache to 1000 entries. When the cache reaches its maximum size, entries will be evicted based on a least recently used LRU algorithm. 3. Expire after write. 10. Time unit. Minutes. * specifies that entries should expire after 10 minutes of inactivity, no writes. 4. Build, key dash. ** builds the loading cache with a loading function. The loading function is a function that takes a key as input and returns the corresponding value. This lambda expression represents the loading function. 5. Get username from database, key, asterisk. This method simulates the process of retrieving a username from a database based on the user ID. In a real-world application, this would involve querying a database using JDBC, JPA, or another data access technology. 6. User cache.get, 123, asterisk retrieves the username for user ID 123. If the username is not already in the cache, the loading function will be called to retrieve it from the database. 7. User cache.invalidate, 123, asterisk removes the entry with key 123 from the cache. 8. User cache.getAll, java.util.concurrentmap, 456, 789, asterisk loads multiple entries from the cache at the same time. 9. Exception handling, in the build method, you should add exception handling, specifically a try-catch block or a cache loader. Invalid cache load exception, to handle loading failures. This is very important in production systems. Step 4, Advanced Cache Configurations. Guava Cache provides several advanced configuration options for fine-tuning cache behavior. Asterisk maximum size asterisk limits the number of entries in the cache. When the cache reaches its maximum size, entries will be evicted based on the least recently used LRU algorithm. Use maximum size long or maximum weight long in conjunction with a where interface, see below. Asterisk weak/soft references asterisk use weak keys or soft values to allow the garbage collector to reclaim memory occupied by cache entries when memory is scarce. Weak keys uses weak references for keys, allowing the garbage collector to reclaim keys that are no longer strongly referenced. Soft values uses soft references for values, allowing the garbage collector to reclaim values when memory is needed. Asterisk where interface allows you to specify the weight of each entry. The maximum weight configuration option limits the total weight of all entries in the cache. This is useful when you have entries of varying sizes and want to limit the total memory consumption of the cache. Asterisk refresh after write asterisk specifies that entries should be refreshed after a certain duration. The refresh operation is performed asynchronously. This is useful when you want to prevent staleness but don't want to block the caller while the refresh is in progress. Asterisk removal listeners asterisk allows you to register a listener that will be notified when an entry is removed from the cache. This can be useful for performing cleanup tasks or logging information about cache evictions. Asterisk stats asterisk enables statistics gathering for the cache. You can use the cache.stats method to retrieve statistics about cache hits, misses, evictions, etc. Example, using maximum weight and where. Explanation asterisk. 1. Maximum weight, 1000, asterisk limits the total weight of the cache to 1000. 2. Where string, key, value, dash value. Length, asterisk specifies the weight of each entry to be the length of the string value. This means that longer strings will consume more weight in the cache. Example, using refresh after write. Explanation asterisk. 1. Refresh after write, 1, time unit. Seconds, asterisk specifies that the entry should be refreshed after 1 second. When get is called after the expiration, the old value is returned while the value is refreshed in the background. Step 5, using removal listeners. Removal listeners are notified when an entry is removed from the cache. This can be useful for cleanup tasks or logging. Important considerations asterisk. Asterisk thread safety asterisk Guava cache is thread safe. Multiple threads can access and modify the cache concurrently. Memory management. Be mindful of the memory consumption of your cache, especially when caching large objects or a large number of entries. Use appropriate eviction policies and consider using weak/soft references to allow the garbage collector to reclaim memory. Cache invalidation. Implement a robust cache invalidation strategy to ensure that your cache data remains consistent with the underlying data source. Consider using explicit invalidation, time-based expiration, or a combination of both. Exception handling. It is essential to handle exceptions that occur during the loading process. Use a try-catch block in your loading cache.build method, or use cacheloader.invalid cache load exception. Best practices. Use the right eviction policy. Choose an eviction policy that is appropriate for your application's needs. LRU, least recently used, is a good general-purpose policy, but other policies may be more suitable in specific scenarios. Monitor cache performance. Use the cache.stats method to monitor the performance of your cache and identify potential bottlenecks. Avoid caching everything. Only cache data that is frequently accessed and relatively expensive to compute. Consider concurrent hash map as an alternative. For very simple caching scenarios, java.util.concurrent.concurrentmap might be sufficient. However, if you need advanced features like eviction policies, refresh policies, or statistics, Guava cache is the better choice. Think about cache size. Overly large caches can cause memory pressure on your application. Too small and it's not worthwhile using the cache. Experiment to find the optimal cache size. By understanding the concepts, configurations, and best practices described in this tutorial, you can effectively leverage Guava cache to improve the performance and scalability of your Java applications. Remember to adapt the examples and configurations to your specific use cases and requirements. Good luck.